So this part already mentioned, yeah, about the population and samples. Yeah, so we given very big data. Yeah, so I mean with a very big number. So uh, usually we take some part and it called as samples. Yeah. And also by the end of this lecture, I'm going to uh, give you assignment one. Yeah, so I will show the assignment one and explain, because assignment one is individual assignment. So you have to submit the assignment, yeah. And the weightage also, yeah, quite big, yeah, for this coursework, yeah, because of the coursework usually is 80%, yeah, in total, but we uh, divide into some assessment or assignment, yeah, not only one time, yeah, assignment one, assignment two, and also some tutorials or practical, yeah, and we have a test as well, yeah, test, uh, practical test, yeah, and also theoretical, yeah. I will see, yeah, which one more appropriate to assess this kind of module, right? So in this lecture today, so we are going to construct, yeah, the report based on the data given, yeah, like this, yeah. Then uh, I will show you the example, then you just create based on the example, yeah, given, and after that create by your own self, yeah, to try to explore more, yeah, to be familiar with Excel, yeah, because of, as I mentioned, Excel is uh, the most important tools in this module, yeah. So mostly we use Excel, though sometimes we try to use SPSS. Yeah, I will show you also how to install or how to prepare, yeah, how to use SPSS. All right, so we have done this one, yeah. Later you should organize all this exercise, yeah, or like this with try this with Excel, means that you have to try with Excel and provide the report individually, yeah, in order to be familiar, become familiar with Excel, yeah, itself, student, right? So we have done, yeah, this part is try with Excel also. So because of Excel actually uh, quite powerful, yeah. I mean, in terms of the tools, yeah, we can find anything that we want actually in Excel, yeah. So summarizing, yeah, it's done already. Central, yeah, I mentioned, yeah. Central tendency, mean, yeah, this one average, yeah, we can say as average and mean, and the difference between uh, mean, median, and also mode, yeah. So mode, this one, and we can see this is if symmetric, then median, mean, and mode are exactly in the same position, same location here. If it is symmetric, yeah, so exactly in the middle here. Yeah, with this, we can say normal distributed. So it will be exactly symmetric here. And if right skew, as you can see here, so mode, mean, median, the location are different, yeah. So as you can see here, so mean will be affected by the, you know, the outlier here. If there is a one some data, yeah, outside of the normal one, so then it will affect to mean, yeah. The median is not so, and mode is, the position is here, yeah, exactly. So measures of dispersion also finish. And then this one, try with Excel later. You should provide this one also. Yeah. And measure of dispersion is interquartile range. Yeah. So we divide the normal distribution, the data, into 4 parts. Yeah. The first part is Q1, Q2, Q3, and Q4. Yeah. It's variance. Yeah. So the larger of the variance, the farther the individual cases are from the mean. Yeah, this one. Small variance, the closer the individual scores are yeah, to the mean, this one. So this one, this is deviation. Yeah, to calculate the variance, start with the deviation. Deviation is distance away from the mean, yeah, of the case score. Yeah, mean is average, as we say. So this is the value and minus the mean. Yeah. So the average person car cost, yeah, for example, here 20,000, car worth 1,000 as minus 14. So deviation from the mean is 6,000 minus 20,000 and equal to 14,000. So deviation, this one, yeah, is mentioned. So for example, the value is this one. Yeah. So the deviation of the first one here is 102, yeah, minus 110.45 minus equal to minus 8.54. Yeah, so 110.54 is actually the mean. Yeah, the mean of the data. In this case is IQs of class of the 13 students. Yeah, yeah, class A in here. Right, so there is a 13 data. So then we calculate this one. Yeah, then got the mean here. Yeah, and after that, how to count mean of each data. So we just deduct or minus by 110. Yeah, I mean 110.54 by minus the mean, yeah, of all data here. So can you do this one? This is for the first data. Yeah. So for the second one, yeah, 128 minus 110 and 40. Oh, sorry. $110.54. Yeah. This is equal what? Equal what? That's one. This is for the second one. So please calculate all. Can you do this? Yeah, you can use a piece of paper or some papers. Just prepare, because we'll perform some calculation for this lecture. And then for 131, yeah, 131. So 131 equal 1154. Yeah, all 98 equal minus 11 0.54. 140 minus 110.4 is 140, and then 93 minus all minus average or the mean, all minus mean this year, and 110 minus 110, 54. This one also 115, for the next one 115, 109, 89, 106, and then 119, equal what? And then 97, the last one. Okay. So this all for the calculation of deviation for this data, right? So understand this part, because you have to know for each of these in descriptive analytic, all these parameters, the calculation. It is very important, to know this, to understand, especially because of in test, in exam, usually we will calculate some data given, and then after that you find, of course, to solve the problem provided. All right, so understand this part, right?
Yes, sir.
Yes, sir.
Yeah. Okay. Very good. All right. So deviation. So for the deviation squared, here. So the same using similar formula. Only because of squared, can put this squared also. Put the power 2 here. Yi minus y with bar here, mean or average, and square for both. So the result should be square. So back to the IQ data that given, the deviation square for for 102, is equal this one to calculate 102 minus mean, mean is this one. Yeah, 4 and square, right? So this one equal to 102, try 102 minus 110.54. Okay, and then is minus 8.54. 8.54 square, power 2. So yeah, 72.93, right? You got this? Did you get this number? You try, please try to execute, to follow this, because you have to be familiar with this calculation. So with this formula, and then how to execute this formula. Can you get the same number here?
Yep.
Yes.
Did you get this one? Okay, good.
Got the same, sir.
Yeah, all right, good. Okay, very good. All right, so then for another example here, yeah, because just to confirm also, I found some of the result are not the right one. So maybe if this is not the correct one, so please revise or please inform me here. Yeah. This one, yeah, the same way, yeah, 115 minus the average or the mean, yeah, to calculate, yeah, and square, yeah. So then 4 point, yeah, 4 point, using your calculator, try to execute this one, yeah, and the result is, yeah, is it right answer, or just confirm, yeah?
Yes, sir. It's the correct answer.
Correct
Yep,
answer.
it's the correct answer. Yeah,
Yes,
Yeah.
same.
Same, sir.
very good.
Same, sir.
Yes, good. Okay, so this is the deviation, and then sum of square deviation. Yeah, this one. So you have to add all the square deviation. Yeah, this one, the square deviation. Yeah, we add all the square deviation. So we'll get, we call as the sum of the square. Yeah, this one, SS. So actually sigma I from yi minus y bar, yeah, square here. So when we describe the calculation, is actually we add all the square deviation, yeah, until yn minus y bar, yeah, square, yeah, until finish the data. If we have 13 data here, this one, so we just enter by one, yeah, this one. So please check this one. So because I don't think this is the right answer. Just please confirm. Can you do, please?
Okay, sir.
Yeah, please. Then
On
because
it.
I
On
think
it.
yes.
On
please.
it, sir.
Yeah, because as I think you should all try to perform this calculation, yeah, to execute this calculation, because of in the test and also the exam, you have to perform this one also, yeah, this kind of calculation. Otherwise, then if because you have to be familiar with this kind of formula, or then maybe difficult, yeah, to solve this kind of calculation or problem during the given time. Yeah, if you are not familiar with this calculation, with the given formula. If you are familiar with Excel, also you can use Excel actually to provide the sum of squares. So there is I will show you one very good book, yeah, for Excel, like a dictionary. So you can find anything that you need, yeah, like sum of squares, variance, standard deviation, so the syntax and how to perform this kind of calculation by using Excel, from the basic until advanced. This dictionary of Excel, advanced in Excel. This one we got there already, so because we calculate also, and then perform by Excel also, by even by SPSS, we got the same number here, and the same mean.
I got the same answer, sir.
This one,
Same answer.
Yeah, same answer.
Same answer.
right? Yeah. And other, please. You Akil, you got the same, and how about the others who have done this calculation? Please inform whether it is the same or not, because of almost of you, I mean, all of you, for example, some of you got the same, then it's fine. Yeah, if majority got the same, then will be fine, will be good. Yeah, I mean, this is the correct one, or the right one. Yeah, okay, Junji also got the same. Yeah, please, if you cannot speak, I mean, you have problem with microphone, can just write down here. Yeah, each of you got the same answer. This for sum of squares. Yeah, please write down. Yeah, type on the chat, yeah, meeting chat, so then I can see. Yeah, please try to perform. Yeah, because yeah, you have to be familiar with this kind of calculation.
Sir,
Yes.
Also, I think I got the same also.
Okay. Good.
Khairil also got the same answer, sir.
Yes. Good. Yeah.
Ada. Nampak sahabat nama aku.
Khairil, you can type in the message box also, the chatting. Yeah. Some of,
Yes,
I mean,
sir.
yeah. Please, just if you get the result, then please type here. Yeah. If you can speak also good, but if not, you can type here also. Because this is just 13 data, right? We have only 13 students here in this data. Yeah, class A for IQ of the class A for 13 students. Yeah, in the class A. So we have a 13 data. So what happens if, let's say, 50 data and start? Yeah, of course it will be more complex or more complicated. So then you need a tool to perform this calculation. Yeah, otherwise, then maybe we will missing some number. Yeah, very good. That's one also. Yeah, got the same answer. Yeah, with Excel also got the same answer. Yeah, very good. Yeah, was the also got the same answer. Yeah, Rashidi. Yeah.
Yes, same, sir, same.
Yeah,
Same answer.
Wasif. Okay, good. Kalpei also got the same. All right, so then, yeah, this is the right answer. Yes, because I already counted again this one before, because previously this is not the answer, so I corrected this one. So, but I think because it relates to the other calculation also, so then please you try also manually here, yeah, or by using Excel, and confirm this is the right one. Right. Okay, so we continue for the next. Okay, the variance, the last step. The approximate average sum of the square is the variance. Yeah, approximate average sum. So variance for a population is SS. Yeah, SS is here from here. That's why the sum of squares will affect to the next calculation, right? If we did this one, we give the wrong answer. This one, yeah, not the correct one. So then we'll affect to the next to here, right? To the variance. That's why it's very important. Yeah. So this calculation is very important, SS, because of the variance. Yeah, we see here variance is the actually SS. Yeah, over n. Yeah, the variance of for a population. And for a sample, yeah, this is population, the whole data, yeah. For a sample, so when we take the one sample, for example, so as the variance will be SS, yeah, sum of squares here, sum of squares divided by n minus 1. This is for sample. Yeah, and this one for the population. Right. So then the variance, yeah, is equal here. Yeah. Sigma I, yeah, in bracket yi minus y bar, yeah, square divided, yeah, by n minus 1, yeah, over n minus 1 here, yeah, for sample. Right. So SS is actually this one, right? This is SS. You got this one, right? So then this is variance. Yeah. So check the result here. Yeah, whether this is right or not. So for class A, yeah, IQ, the variance is this one. Yeah, so you find this is SS, yeah, from the previous result divided by n. Yeah, n is the population, yeah, number of students in total. Yeah. So n is 13, yeah. So then please check the result.
Got the same result.
Yes.
I got the same result
answer.
also.
Yeah, good.
Same answer.
And try if you have Excel, if you try you using the var, yeah, on the Excel, yeah. But then in Excel you have to count, you have to enter this one by one, yeah, this data, and then you find the sum SS, yeah, sum of squares, and after that you can find this one, the variance, yeah, VAR, yeah, the set syntax in Excel. Yeah, I will show you later on the second session. Yeah, I will show you about this one, the practical thing. Yeah, you can refer to the books. Yeah, there is a very good books actually. Yeah. I'm not sure whether you can download this book or not, but then we'll see on the next on the session, in the next session, this one. Because of in this lecture, you should provide simple report for this, yeah, by using Excel only. Yeah, calculate all of this. Was it the analytical, descriptive analytic here by using one form of the Excel, yeah, but with some instruction, yeah, related to SS, deviation, yeah, mean, mode, yeah, variance, yeah. Yeah, so in order to become familiar with Excel, yeah. Okay, you got did you get the same? Yeah, or
Yes, sir.
you still try with Excel? Because I already share this. I sent to CR, yeah, plus representative, all these materials. So then you can check, yeah. I mean the data here, the class A, even class B here, yeah, from this one, from the original data, yeah, and then you create by using Excel. All right. Yeah, very good. So then, so what does mean this all statistical measure? Yeah. So then we will continue on the next slide. Yeah. Yeah. Before end of this slide, yeah, the function or the parameters of the statistical analytic. Yeah. Yeah. How it is useful for to solve some problems. Yeah. So measure of dispersion, yeah, for standard deviation. So to convert the variance into something of meaning, yeah, to the unit measurement. So we create the standard deviation is created here. So the square root of the variance refers the average deviation of the observation from the mean. Here, the standard deviation. After we got the variance, so then we perform the square root of the variance, and then this is the formula. Yeah. And the formula of as I mentioned, variance is very important because of it will affect to the next calculation. Yeah, here, yeah, to standard deviation. So standard deviation equal to square root of variance. Yeah, so this is variance sigma I. Yeah, bracket in the bracket yi minus y bar, yeah, square, and then divided by n minus 1. This is for a sample, yeah, for one sample. And then this is square root for this variance. So this is the formula for SD or standard deviation. Right, so then for class A, yeah, the standard deviation, yeah, actually so please calculate, yeah. So this is not the right answer. That's why I mentioned to you, yeah, some of this in this slide, yeah, maybe not the right one. Yeah. So class A standard, can you calculate here? Yeah, so actually square root of variance. So variance we got this one, right? Or minus you have to n minus 1 first. Yeah. So just check whether this is the right answer or not. Because so the total, yeah, n is 13. So when you minus 1, 12. So it is the same answer or not? The standard deviation. Try to find the standard deviation of this data, yeah, for class A. 2891.23. Right. Yeah. Try to use the Excel also, yeah, to find this one. Standard deviation of class A. Yeah, SD. So I will show you the book, yeah, for this. Yeah, advanced Excel formula. All right. So can you see
Can see.
the book here in PDF?
Yep.
Okay, good.
Can see, sir.
All right. So this is actually very good reference, yeah, for you. So in this part, yeah, the content here, yeah, Excel function dictionary, yeah. Try to find this book, yeah, yeah, maybe in UTB library, e-library, or maybe you can try to find on the internet. Sometimes people or maybe publisher provided this one, or some other website. So in this part, so you can see the function, all the function here. So then you can easily find this function, on the Excel, the location. This is with the analysis toolpath, then you have to see it on the analysis toolpath. Within then available analysis toolpath means that you have to add the features on the function. So then that is all. Some if, some product, many, even far here. Can you see here far?
Yes, sir.
VAR, statistical will estimate variance based on the sample. And VARP is calculate variance based on the entire population. So VAR just based on the sample, and with P for total population. And then, of course, the standard deviation is there. You just find here Control F. And this is I think ST. So you check whether this is the standard deviation available. Or we try the standard deviation first. This one. So standard deviation, there is a 2 also. Can you see here?
Yeah, can see.
Yes.
So we can use STD-EV. This is for standard deviation sample. If we put P, then this is for population, entire population, right? So if sample means that we take the sample from the population, as I illustrated at the beginning of this lecture, about the descriptive analytic. So what does mean of population and what does mean of sample? So these are so we can see how to perform this kind of calculation on the Excel. We found this, then we go to this one, STD, for example, EVS, STDEF, standard deviation. All right, so this is how to perform. So you got this. Can you see here?
Can see.
Can
Yes,
see?
sir.
Okay, so then this is how to perform on Excel. So after first, you find the standard deviation. Fine. And if you got the syntax here, and then after that you find on details of how to perform or how to calculate based on how to use the standard deviation in Excel. So if you have values like this, in our data we have a 13, right? This is only 4, 13. So then you just easily this one. For example, this is values of the class A IQs. Class A IQs, and then you just type all the IQ on the Excel, one by one until 13, and then you calculate this one, standard STD-EV, in the bracket, and you just highlight which one that you want to include. For example, here is where this one based on the Excel table. You can see. I will open this in a draw box. Yeah, so then I can write down the formation here. Because here I'm not sure whether I just maybe I can only do by highlight this one. What the text and maybe highlighting this one. Yeah, so you can see here, this is C. And this is C here. Okay, not that. All right, so C, yeah, and then this number, right? On Excel, you can see here, number, yeah. I mean the row, yeah, row number. Yeah, so if you want to count the standard deviation of this data, so you put this is column C, yeah, here, and row number 4, right? So that's why C4, yeah, C4 here, and up to, yeah, you put this one, yeah. Oh, sorry, symbol, yeah, and after that up until C7. Sorry. Right. Yeah, so from C4 until C7 here. So you will get this one. So you can try for the data given, yeah, IQ of the 13 students, yeah. So then try to find this one, yeah, whether you get. This is for standard deviation for the sample. Yeah? So if for so then you can find for each. For population, you will perform different using different syntax here. So this function calculates the sample population standard deviation of a list of values. Yeah, sample population is used when the list of values represent sample of population. So syntax is the syntax. So range, yeah, you highlight the range, yeah, from range 1, for example, range 2, 3, and so on. No special format, yeah, yeah. So then you can see here. The below was used by a company, so this is the sample. You can also perform. You can also try this. Yeah, this one. Whether this is. Yeah, please be familiar. Yeah, please try you create this kind of table and check. Yeah, and execute by using this syntax. Yeah? By using STDEV, yeah, standard deviation syntax. Yeah, yeah, and then whether you get the same result or what. Yeah, and then from this, yeah, this is one example. Yeah, one example of the problem. Yeah, the table below was used by a company interested in buying a new machine, for example. Yeah, machine to pack washing powder. So 3 machines were shortlisted and allowed to run for a day. At the end of the day, 4 boxes of soap powder were picked at random from the production of each machine. And the boxes were weighted, and the STDEV function used as these boxes only represented a sample of component. The machine with the smallest deviation was the most consistent. So try to use, yeah, this syntax and find the standard deviation for each. Yeah, the variance, yeah, and the standard deviation. Yeah, this is the variance. Yeah, this standard deviation. So the smallest deviation is this one. Yeah, by this result. Yeah, yeah, and then the machine with smallest deviation is, yeah, as we can see, machine number 2. Yeah, this is the smallest, 0.05. Yeah, and then the index is this one. This is explanation of the formula. So this find the lowest value, yeah, mean this one. So then you will get this one. And then this find the position of the lowest value, yeah. Match this one to match, mean, yeah, H34, yeah, H36, yeah. And then this one, the index, yeah, this look down the machine column to find the machine name. So it will appear machine 2 here. Yeah, when you when you type this syntax, then it will appear machine 2 because of with the minimum value of the deviation here 0.05. So please try this part by using your Excel, then try to get the same like this with the standard deviation. Yeah, you can see from the Excel how to find the standard deviation actually from the function. I will show you for in Excel. Yeah. Excel. Yeah, when you type std, then it will appear automatically. Yeah, std what, for example, std def. Yeah, then yeah, or you can use the this is auto sum. You can find more. This one I show you. I stop this part. So first you find this book, yeah. Whether you can get this book or not from the internet, please. Can you do this? Find the book first, then after that you can easily to find because this is a function dictionary. So then we can easily find the function and how to perform or to execute the problem and solve the problem by using this kind of function in Excel. Can you find this book, please? This is the book, the title of the book. Excel function dictionary. Can you see?
Yes, sir.
Yeah, please try to find this book first. So then you can easily to practice, to perform or to execute, to perform some practices here. And yeah, of course, you can just refer to this book. Yes, and you can try and please train yourself or perform many practices, many practical things, to solve the problems, and then with the from the simple ones, the simplest, very simple, and after to the complex. I mean, until or up to the complex problem. Yeah. Later on, we'll show you some example also. Yeah. So this book, try to find. So then on this book, we can find all the things that we need here. Yeah. On the statistical function, right? So then if you got this book, then later I show you how to find in Excel. You just type this one, or you can see also in Excel. Yeah, this is the Excel. I will show you. Okay, this is just one example. So you can find, yeah, can you see the Excel? You see the table, the blank one?
Yes, sir.
Okay, please.
Yeah.
So then there is
tampak,
a, yeah, good. So this one, yeah, the tool bar here, yeah. So you can see, yeah, home, insert, draw, page layout, formulas, yeah, data, yeah, and then review, yeah, yeah, all you can find here. And then for this one, yeah, we can see the this one, yeah, you can see the from more function here, from formulas you can find from formulas, yeah, yeah, means that the function you can see here. So this it actually been categorized, yeah, already categorized here. So financial, logical, text, date and time, yeah, lookup, reference, math and trigonometry, yeah. And more function you go, then you go to statistical. So then you can find many function, statistical function here. See, yeah. So then like this, yeah, SDIF P, yeah, for population, yeah, P number 1, number 2, and so on. Yeah, this for sample, yeah, yeah, sample. So in this function, because this updated version, yeah, in the book, yeah, it mentioned only stdef, yeah, that is for sample. But in this Excel, yeah, stdef .s, yeah, for sample, and stdef.p for population. Yeah. So you can see also here, yeah, when you point this function, then it will appear the explanation of this function. Yeah. So like this one's stdef point p means that calculate standard deviation based on the entire population, yeah, given as argument. Yeah. And then for stdef, yeah, .s, yeah, it is estimates standard. It estimates the standard deviation, yeah, based on a sample. Yeah. So if you need more information, you just click tell me more, right? So this is variance. Yeah, also you can see, yeah, VAR, yeah, var.p, yeah, this it calculates variance based. Sorry. Okay, so continue. Can you see again?
Yes, sir.
Okay.
can see, sir.
All right. So I repeat the explanation. Yeah. Go to the formulas. Yeah. Yeah. And then find more function here. Then you can see statistical. Right. Can you see? You can try directly from your Excel, yeah, on your laptop or notebook or PC, and yeah. So then you can see if you want to find average, yeah, just on the average. If you want to find the variance, you go for variance. VAR here, yeah. This for population, this is for sample. Yeah, so then how to execute, then we can see on the the books, yeah, that I showed to you. Yeah, I mean how to write the this one also appeared like this number, yeah, from this one to this one, for example. Number 1 to number 2, yeah. So it mentions variance from number 1 and number 2. Yeah, if you have more, then you have to follow the difference You use the different syntax. All right, so some deviation. Yeah, this is a this smallest number, median is available here. Yeah, so we don't have mean here, so we use average. Yeah, so the same meaning, average. Or I think you can median. Yeah, maybe you can type just. I'm not sure, but if you put mean, what will happen? Yeah? For example, here and put the formula. I need to. You need to write down the number first. Yeah, for example, 10. Yeah, 12. Yeah, 15, 20, or let's say to make it easier to calculate 20, 30, 40, yeah, 50. Right, so this one should be 10, 30, 60, or 150, right? 150. So we find the mean, yeah. Check. Whether it appear or not, the function. Oh no. So you cannot use this one. So you should use the formula given here. Yeah, for average, for example. Oops, way back to B2 to B7. Right. No. Yeah, you have to highlight this one. Okay. Yeah, this is the average. Right. So the average number here, yeah, you can see. Yes, correct. Yeah. Then you just explore, yeah. You can explore this one. Yeah, from the formulas. Yeah. right? So can you do this? This is not, it's not difficult, yeah, for computing student actually. Yeah, for CS or IT student, it's not difficult because of we are, yeah, supposed to be familiar with this tools, yeah, this kind of tools, yeah. So then, yeah, still not no coding, yeah, just using toolbox, and we find the function, then apply the function, yeah. Right? Only there is a syntax available, and the meaning of the syntax, meaning of the function, then we just type, yeah, or use the formulas, yeah? And after that execute, yeah, implement. So can you do this part, this one? So try to find the standard deviation, yeah.
Sir, are you screen sharing right now?
And not yet, not yet. Yeah,
Oh, okay.
yeah, this one. Okay, I changed from Excel to again PPT. So can you see?
Yeah, can see.
Yes. So please find the standard deviation for this class A, right? So because of you have the data of class A, right? The IQ's data for the class A. Yeah, from the slide given, right? This one, from this one, there is a IQ data of class A, and you type one by one for each data here. Yeah, 102, 108, 131. Yeah, all until 13, and after that, try to find, yeah, the standard deviation. Yeah, at the end, I will give you yeah, I mean the exercise, yeah, for to perform all this and create the organized simple report, yeah, for Excel, yeah, just one page of Excel with standard deviation, means, yeah, mode, variance, yeah, with some, I mean, content inside. Right, so we continue this one first, right? So standard deviation, yeah, so larger standard deviation means greater amounts of variation. That is the meaning of standard deviation. Means that it is a various, yeah, the variation is very great, yeah. That is the meanings of the standard deviation. If greater, then the amounts of the variation, yeah, will also great. Yeah? So around the mean, yeah. For example, this one, yeah, standard deviation is 6. Yeah, the was it the mean, yeah, here, yeah, 25, right? So because of there is a 19, yeah, you can see here 19, 31, 25. Okay, so from this data we can see, yeah, the mean. How much the mean? Can you see? Can you write? Can you count? Is it right? 25? How to count this? How to get 25? From where? This is the mean.
Yeah, it's 25.
25, sir.
Yes, great. So from
25, sir.
from where you get this? You got this 25, 19
Add
plus,
all three
yes,
numbers
yes,
and then
correct.
divide by 3.
Divided by 3.
Correct. Yes, correct. Yeah. Then divided. It's all plus. Yeah. Add all this number and divided by how many numbers that appear here. So divided by 3. So you got 25. And then with this one, we can see, yeah, the standard deviation is 6. Yeah, the deviation is 6. Yeah, actually from 19 to 25, there is a 6 number, right? I mean the difference.
Increase.
Yeah, increase
Yeah.
by 6, or the difference between 25 and 19. Yeah, 31 and the 25 is 6, right? So, and then the other one, yeah, this one from the second graph, yeah, we see actually the same data. Yeah, we have a 3 data, yeah, 13, 25, and 37, and then we got the same mean. Yeah, can you check the mean? Is it right? 25?
Mean is
Yep,
correct, sir.
it's 25.
Yes. Okay. So then 13 plus 25 plus 37 divided by 3. Then you got 25. But when you see this data, the standard deviation is 12. Yeah. From where? Actually, the incremental, yeah, the increase or the difference, we can say. From 13 to 25 is 12. Yeah. From 25 to 37 is 12. Right? So that's why when we get the large standard deviation, yeah, means that we have a great amount of variation. Yeah, the great amount here. Yeah, because of when standard deviation is high like this, at 12, then the variation will be great. Yeah. Yeah, if compared with this one, this is a small standard deviation. So the variation, of course, also small, right? So that is the meaning of the standard deviation. Did you get the point? Understand from this?
Yes.
Yeah,
Yes.
good. Yes,
Yep,
very good.
understand.
Okay. So then if the standard deviation is 0, yeah, only when all values are the same. If all values are the same, then not standard deviation because of no variation, right? So for example, these are 3 data, right? So we put 25, 25, and 25. So all the same. The mean also 25. Yeah. The mean also 25. But standard deviation is 0 because of maybe there is no variation at all. Yeah, just the same number. If you have the data, 100 data, all the number are the same. Yeah. For example, 15. Yeah, 100 data, also there is no standard deviation because there is no variation. That is the meaning of standard deviation and variation. Right? So it has a strong relationship. That's why when we calculate, make sure to perform the right calculation, the correct calculation for variation, because of at the end we use variation to count the standard deviation. All right, so that is the meaning. So if standard deviation 0, we can get SD equal to 0 when all values are the same. Yeah, when we have a constant, yeah, that is no variable. Yeah, not a variable. Yeah. So if you were to rescale a variable, yeah, so standard deviation would change by the same magnitude. Yeah, if we change the unit above by a multiple of 10, yeah, the mean becomes, yeah, of course, 250. Yeah, if we multiple by 10, yeah, then the mean will be 250, and the standard deviation on the left would be 30, on the right would be 60. Yeah, that is the Orchard standard deviation if we change, yeah, multiple of 10, yeah, for example. So 250, and then the difference, yeah, will be 30, and the other one will be 60. So like the mean, the standard deviation will be inflated by an outlier case value. So if there is outlier, so then standard deviation also will be affected. Yeah. All right. So these are the practical application. Yeah. So I mean the case. Yeah. Variance and standard deviation. Yeah. Even though we live in a world, yeah, where we pay real dollars for goods and services, yeah, not percentage of income. Most employers issue raises based on the percent of the salary. Yeah. Why do supervise things the most raise this? This is the one example, yeah, of the application yeah, for variance and standard deviation, like to calculate the salary. So to see, to observe whether the variance of the salary is high or that is acceptable or unacceptable. Yeah, because of high paid person win the most money. Yeah, that is true. Yeah, higher paid person win the most money. And the easiest things to do is raise everyone's salary by a fixed percent. Yeah, that is happening in many companies. Yeah, actually, to calculate to make the variance low. So just raise the salary everyone's by a fixed percent. Yeah, but is it the fair way to perform this rules? Yeah, if your budget went up by 5%, salaries can go up by 5%. Yeah, so the problem is the flat percent raise gives unequal increase reward. That is the thing. Why? Because of the percentage. Yeah, for example, let's say the salary of the one people, let's say 1,000. Yeah, another people, let's say 5,000. Yeah, so then if we implement, apply the same percentage for each, let's say 5%, so it will give the difference incremental, right? Unequal increase. So for example, 5% for 1,000, how much? 5% for 1,000, 10%, 100, all right? 5%, 50. So we will increase 50. And 5% for 5,000, how much? 10%, 500, right? If 5%, 250. So the 1,000 will become 1,050, the salary, right? And 5,000 will become 5,250. So from this, it will give unequal increase, unequal incremental. 1,000 only get 50 incremental, here, and the other one, with 5,000 will get 250, unequal increase reward, right? So if we say that, okay, because of the inflation rate 5%, and should be all the people also get the same. Not really the same, but fair amount. So that's why then we can count, we can calculate. So if we usually for the easiest way, the company will just raise the salary with the fixed percent. I mean the same. For example, okay, increase 3% for all staffs, but then it will give unequal increase for the staffs. Of course, because of some staff maybe have a different reward, different salary for the certain position, because of the position, because of the experience. But it doesn't mean if the staff, for example, work longer time, it doesn't mean they will get the highest salary. Doesn't mean like that. So because of the company, they have a performance measurement, to increase the salary of the people. But if we apply the same 5%, then it will give unequal incremental. Right. So these are the illustration. So the illustration of the case. So cleaning services company, for example, salary pool, 200,000. Then salaries of the president, 100,000 and then manager 50K, secretary 40K, cleaner 10K, for example, a year. We count this one usually a year, right? So the mean of this, so then you can see the mean of this. Can you count the mean of this one, salaries? 100K, 50K, 40K, and 10K.
$50K, sir.
Yes, 50K,
50K,
right?
correct.
Yeah. So you just add all,
Ada tujuh puluh.
all this level, the level
50K.
salary, 100K plus 50K plus 40K plus 10K, right? So we'll get the mean. Yeah, the mean is 50K. And this is the practical application. Yeah, because we have we are facing many problems like this. Yeah, in companies. So this is how to show the application 50K. So the range, because of the range is actually the highest. Yeah, do you remember how to find the range?
Range is 90K.
Yes, correct. Yeah, from where you get 90K? You got 90K. Amirul? You
So
said,
highest minus the lowest.
yeah, it's great. Yes. So highest, 100K minus 10K. So you will get 90K. Yeah, so this is the range. Yeah, so then you can see the variance. Yeah, based on this data, you can try to find the variance. Can you do? You just put on Excel or you can count manually. Yeah, 100, 50, 40, and 10, the number, and find the variance. How to find the variance? You remember the formula, and you know the mean. Yeah, mean is 50. Yeah, to be easy, you just put 100, because if you put K, then too long maybe. 50, 40, 10. Yeah, this actually simple. Yeah, but if you put K, then make it like complicated. Yeah, but actually simple thing. There is 100, 50, 40, and 10. Yeah, so then if you but then this one, because of the number of, if you want to make it, you want to be easy to show on the data, so then you can also put the 0. But then the calculation will be, of course, more numbers. So if you get the variance, and with the standard deviation, actually the standard deviation, as you see from the previous slide, here, this is the variance, right? And then this is standard deviation. It's actually the square root of variance. So then this one, this one, this is a variance. How to calculate the variance here? So sigma I, from yi minus y bar, square. Y bar is mean. So then you have to perform like this, all. Sum of square, right? With the number 100 minus mean, and square, plus 50 minus mean square, plus 40 minus mean square, plus 10 minus mean square. So then you will get this one, the data. And then the variance, you have to divide by the number of the population. If you take for the population, for the whole data, and then you get the variance. You know how to calculate the variance here? You have to find SS plus, right? And after that, divided by the population. And then after that, you find the standard deviation from square root of variance. Yeah, so then this can be considered measures of inequality. Yeah. Right. So measure of inequality. So now let's apply a 5% raise. Yeah, if we put the incremental of the salary 5%, so then what will happen? Yeah, of course, yeah, as I mentioned before, I illustrated. Yeah, 100K, you will get, if 5%, then 100K will get, yeah, plus 5, right? So 5% from this one, 10 plus 5, so 105K. Yeah, for 50K, will reach, will increase 5% from 50. So 10% is 5. So 5%, 2.5K, the incremental. Right. So then it will rise 5K. Right. A year, it will rise 2.5K. It will rise 2, right? 2K because of 5%. Yeah. And it will rise only 5% only. How much this one? 10% is 0.1. This is 1K. You have to find. Yeah, 10% will be only 100,000, right? 100, right? Sorry, 1,000. Because of 1,000.
1,000.
Yes, and then 500.
Yeah.
This is 5%. So it will be only 0. So 500, 0.5. Yeah, the incremental will be 0.5, right? 0.5K. Yeah, even less than 1K. Yeah, because of 500 only. This is I apply here. Yeah, 0.5K only. Yeah, so the incremental, if you see it here, yeah, this is, yeah, of course, this is unequal, yeah, right? So measures of inequality. So because of we get higher salary, we'll get highest incremental, isn't it?
Yes.
Yeah.
Yes, sir.
So this is actually inequality, yeah, unequal, right, for each. So because of we get higher salary, then we get higher incremental. If we put the same ratio here in this case, 5%. So it is happening in many companies actually. It's just because of they don't want to make it complicated. Just okay, give 5% raise for all staffs, then will create an inequality for this. All right. So after, yeah, we can see here after a 5% raise, yeah. So the pool of money increases, yeah, by 10K to 210. Yeah, because of, yeah, as we can see here, yeah, this is, yeah, 5K plus, sorry. So because of we increase the salary, yeah. So 5K plus 2.5 plus 2 plus 0.5. So we increase 10K actually here. So the pool salary pool will increase 10K. So will be 210K. Yeah, for the salary pool. Right? Because we increase 5%. Right. So after a 5% raise, the pool of money increases by 10K, to be 210K. Because of 5% incremental salary. So president will get, yeah, as I mentioned before, 105K, and manager will get 52, yeah, because of increase 5%, increase incremental value, incremental salary is actually 2.5K. So we'll get a 52.5K, and secretary will increase 2K, then we'll get 42K. And then cleaner will get 10.5K. Yeah, so the mean, yeah, is actually 52.5. Can you calculate the mean from the new salary here after increase 5%?
It's 52.5.
Yes, great. So yeah, this is the mean, yeah, 52.5K. So went up by 5% exactly, right? And the range, please, can you count the range? Yeah, so the highest minus the lowest.
94.5.
Yes, very good, this one. And went up also 5%, yeah, from the original number, from the salaries pool, yeah, from the previous one. So the variance, yeah, will be this one, yeah, from the previous one, the variance is this one. Yeah, right. Yeah, so 1 billion, and then this one same, but you can see the difference here. Yeah, still 1 billion, but difference, yeah, 157 million here, right? So you can see the variance. So no higher than before, the variance. Yeah, so standard deviation, yeah, up 5%. Yeah, from 32.4. Yeah, and the measures of inequality, this one. So the standard deviation as a measure of inequality went up by 5%. The flat percentage raise increase in equality. Yeah, so that's why the flat percentage will raise the increase, yeah, in equality. So flat percentage raise increase in equality. Yeah, because of inequality, become higher than before. Yeah, before the inequality here. Yeah, now higher. Yeah. See. So the top earner got 50% of the new money. See, the bottom earner got only 5% of the new money. Yeah, I mean the new pool of the salary here. Yeah, so this is last year statistic. Yeah, you can see from the previous year, previous one. So 100K, 50K, 40K, 10K. If we just raise flat number, yeah, flat or fixed flat percentage raise or fixed percentage raise just 5%, then yeah, it will create, inequality higher than before. Yeah. So then it will create, yeah, the gap, yeah, between the highest and the lowest becoming higher also, right? So because of the range, yeah, before only 90, yeah, now the range becoming 94.5, yeah, from the highest to the lowest. See the variance before this one, and standard deviation this one. So after we increase 5% all at the same or the fixed rate, yeah, the flat percentage, then it will create the higher inequality. Right? Understand until this slide?
Yes, understand, sir.
Yes.
Yes, sir.
Yeah, very good. Yeah. So these are, the function or the useful of the statistic actually. So with the statistic, after you learn this kind of data analytic, part of descriptive analytic, so you can make some decision actually. Yeah. So that's why nowadays, the business decision, is actually yeah, based on the data analytic. Yeah. So if we have a big data, then we should perform big data analytic. Yeah, to result or to create a very important decision for the company. Yeah. Yeah, like the incremental salary incremental or salary increase. Yeah. Because of this one is very important. So then we can justify based on this calculation. Now, whether we just make the same flat or the flat rate of salary increase or incremental, or we create some groups. Yeah. Okay. For example, the management groups. Yeah. Maybe the incremental only 1.5% or 2%, and the operator groups, yeah, the operational groups, maybe the incremental should be, let's say, 5%. Yeah. So then to make, the inequality not becoming very high or higher than before. Otherwise, then the gap will be high, and it will increase every year. The gap becoming very high, high. Yeah, almost. Yeah, then we can say the lowest earning people will be, yeah, of course, in difficult situation, and the highest one will be, of course, the convenient or very easy life, like something like that. Right. So since we pay for goods and services in real dollars or not in percentage, so there are substantial more new things that top earners can purchase. Yeah. So then you can see, yeah, the top earners, yeah, the highest salary can purchase compare with the bottom earner for the rest of their employment years. Yeah. So because of the bottom earner, yeah, or the lowest earner, yeah, only increase, let's say $500 a year, right? So then, yeah, of course, the buying power or spending power will be, yeah, totally different, right? Because of the incremental also, yeah, different. And then the cleaning service company is giving the earner magnitude, yeah, different from 5,000 to 2,500, 2,000 and 500K more, respectively, each and every year forever. That's the thing. And because of we implement the flat incremental, yeah, a year. So then will create the gap, yeah, more big, yeah, bigger every year. Yeah, so the gap between the rich and poor expands. See, this is the story behind. Right? So then the earner, the highest earner, will get, yeah, of course, yeah, in terms of the spending power, purchase power, buying power, yeah, power they have, yeah, more than the lowest earner. Yeah, so the gap between the rich and poor expands. So this is why some progressive organization, right, give a percentage raise, yeah, percentage raise with a flat increase for lowest wage earners. Yeah, for example, 5% or 1,000, whichever is greater. Yeah, this is only with a flat increase for lowest wage earner. Yeah, so not for the management, right? Because of it will give a different value, yeah, in terms of the money, right? So then, for example, 5% or 1,000, whichever is greater, yeah, for the lowest earner. So then we make it, if it is below 1,000, then we will make incremental to be 1,000. Yeah. For example, this one, yeah. The salary only, let's say salary 10K per year, and if 5% flat, yeah, supposed to be 500 only, all 0.5K. but with this incremental policy, then this staff or these people will get 1,000 or 1K incremental, because of actual calculation is 500. So then with this kind of policy, it will get 1K because of bill below 1K. All right. If it is more than 1K, then it will be based on actual calculation. But if below 1K, yeah, then it will give 1K. Yeah, that is the thing, right? So any question or any comment for this? These are the useful of, actually explain the useful of the analytic, descriptive analytic, based on the data given. So then one example of the useful of the descriptive analytic or statistical analytic is like this, to find the gap, to see the variation, then we can conclude with the available data based on the calculation. We can make a important decision for this. Any question?
No,
No,
not
sir.
any,
So far,
sir.
clear, right?
Yeah, so far
Yes.
clear.
Even, yes, even though it is, it looks like a very, simple, the calculation, but we can read based on this calculation, the data. It means a lot actually, right? So we can see then it can affect to the company's decision. I mean business decision by using this kind of calculation, statistical, descriptive or descriptive analytic. Right. So as for the categorical data, so then the only measure of central tendency we can apply is the mode. Mode is the most frequent value of the categorical variable. The most frequent value. From the lecture, as I mentioned before, the mode can be more than one, right? Can be more than one. So, for example, the most frequent value, there is a two number that appear on the same frequency. I mean the same frequency. So means that the highest frequency. So then we can have more than one mode. There are some measures of dispersion for categorical variables, which are less emphasized compared to those numerical variables. So a common one is the IQF, or index of qualitative variation. IQF. So how to perform IQF? Index of qualitative variation. IQF is a measure of variability for nominal variables, such as ethnicity, gender, religion, colors, and so on. And the statistic for determining the dispersion of cases across this category of categorical variable is like this IQF. So sorry, disconnect. Right, continue. So you can use
It's
it,
okay, sir.
right? Can you see the slide?
Yeah,
Yes.
can see, sir.
Yes.
Good. So this is the IQF formula. So K times bracket 100 square, or 2 minus set 1 to K cat. This is a category I percent square here. So K refers to the number of the categories. cat I percent is the proportion of each value in the categorical variable. And it ranges from 0, only one category. If 0 means that the most homogeneous, and to 1, the maximum variability. 1 for most heterogeneous. And 1 refers to even numbers of cases in all categories. So not that cases are distributed similarly to population proportion. And IQF is affected by the number of categories K. This one. It will affect to IQF. The number of category. All right. So this one example. Problem is University A more ethnically diverse, heterogeneous than University B. Or another version we can say has the ethnical diversity in a university or a city increase or decrease between 2 years or over multiple years. So University A, we can see the percent category, Native American, African American, Asian, Latino, white. So then we can see the percent. This the category. Percent, this category. Right? And then University B, the percent, this one, and this is the category. Native American, African, Asian, Latino, white. The percent. This is the percent. Right? So this percent should be 100%, right? If we count, 0.6 plus 6.1 plus 39, in University A. 0.6 plus 61, 6.1 plus 39.3 plus 19.5 plus 34.5 should be 100, isn't it? Try to count.
Yeah.
Yes,
It is
sir.
100.
Also University
100%.
B, University B, try to count 0.6, 3.9. Is it 100%? Same?
Yeah, 100% as
Yes,
well.
same.
Good. It means that is the right percentage, because we have to make sure that these are the right one, the right data. Right, the solution, calculate IQF for each, because we want to see the diversity in, for example, this is in city or university or any places. So calculate IQF for each university to determine which is higher. So we just find IQF, K, K is category. So how many category here? So refers to number of category. So these are how many categories?
5.
5, yes, because there is a percent, there is category. We have 5. Native American, African American, Asian, Latino, and white. So K should be 5, right? So then you find this one, sigma K1. So this one is sigma K1, this is not, this is wrong symbol. Should be sigma here. Because of from 1 to K, not theta, right? So sigma 1 to K, so category I percentage, percentage is 1. So you just plus, I mean this one, for each, 0.6, because of sigma, from start from number 1 here until 5, category 1, so 0.6 yeah, power, was it the square, yeah, or power 2 plus, yeah, all plus until 5. Yeah, this one, power 2, this power 2, power 2, yeah, plus, yeah, and 100, was it power 2 here, square, minus this category from 1 to 5, yeah. And then divided by 100 square times k, k is 5, yeah, minus 1. So then you will get the IQV. Yeah. So this is another example. I mean, not another example, but this is the solution how to calculate. So you can see here. Yeah, try to count. Yeah, 6 market power 2 is it cut percent, yeah, category? Is it 3152? Yeah, this percent category. So just this one. Yeah, power 2. Yeah, this one square. Is it right? 0.6 becoming 0.36, 6.1 becoming 37.21. Is it the right, the correct number? Please check in order to be familiar. 39.3 if power 2, yeah, is 1544.49. Please check. And after that, this one just you add, yeah, sum up this number, yeah. So then you will get this number. So is it the right number? So please check. And plus this, you will get this one.
All correct, sir.
All correct. Great.
All correct.
Yeah, good. Very good. Yeah. So then how to calculate IQV? Yeah. So as I mentioned, this is 5 here, K, right? And then this is 100 power 2 is equal to 10,000, right? So minus, because of we find A, this one, the university A first, yeah. Yeah. Yeah, we got this number, right? This one. Yeah, from 5 times this one times this number, yeah. Yeah, from this one. This is not here. Yeah, this is mistake because of the conversion, I think. This is sigma, this is sigma. Sorry. Yeah, sigma. All right. Yeah, so you will get this one. 10,000 times K minus 1. Yeah, 5 minus 1. So you will get 40,000. Yeah, 40,000. So this number, yeah, from this formula divided by 40,000. So A, yeah, here IQF equal to 0.856, right?
Yep.
Yep.
And then
correct,
this
sir.
one, correct? All okay.
Same.
Yeah, all correct.
Same.
All right. So if you get this one, so then you can conclude this, yeah, based on this scenario. Yeah, it ranges from 0, almost homogeneous, yeah, if to 1, most heterogeneous. So which one most heterogeneous, A or B? With one more, which one more diverse, yeah, in terms of the what's it, the ethnicity here? The number is which one higher? A is IQV or
A.
B is IQV? Yes.
A is higher.
Yeah, very good.
A.
Yeah, so A, because of A, this one approaching to 1, right? This is less. This one higher. Yeah, this is higher. So means that this one more diverse. Yeah, A is IQV more diverse based on this formula here. Yeah, when you say, yeah, it ranges from 0, yeah, only one category, most homogeneous. Yeah, 1 maximum variability. Yeah, so if approaching to 1 means that most heterogeneous, yeah, or maximum variability 1, but maybe not reach 1, yeah, less than 1, but approaching to 1. So the highest number will be the most heterogeneous or the most diversity. So from this result, we can say University A more diverse than B, right? Okay. So understand until this part?
Yes,
Yes,
sir.
sir.
Yeah, very good. Yeah, then you can try using Excel, this one. All right, so this is the summary, yeah, descriptive statistic, yeah, or analytic, yeah, frequency distribution, histogram, measure of central tendency, measure of dispersion. Now you understand some application of this analytic, descriptive analytic, yeah, or statistic. Yeah, very useful actually, yeah, like this one. So then the question may vary. Yeah? Only actually the calculation is not difficult. Yeah? Only we have to understand the story. Yeah? And then after that, represent the number. Yeah? And we count based on the statistical descriptive as mentioned in this lecture. All right, so finish for the first part here. So we'll continue. Yeah, we break for 1 hour. And after that, continue for the practical. Yeah, I will guidelines. I will show you the guidelines. Yeah, provide all this mentioned in the slide. Yeah, with the Excel. Yeah, with the comment this one. Yeah, try this with Excel, and provide and organize. Yeah, the one Excel sheet. Yeah, to show all this Excel format. Yeah, in Excel. So then you will, I mean, in this case, we try to, to train you, yeah, to be familiar with Excel formulas, right? Okay, so we'll continue after break, right? So I will keep this Zoom online. Yeah. Then please take a was it screen capture, yeah, as usual, to take attendance for CR. Yeah, all CR.
Okay, okay.
Yes, please. So for SDDA first.
Okay. Ke kamera guys. Yeah.
Handsome Joseph.
Ini satu. Okay, semua sudah. Dari ke kamera. Hello.